Let's move on to section 4.2. We're going to talk about expected values. So definition of the expected value is that we have a random variable x. It's a numerical measurement of the outcomes in an experiment. And then the expected value indicates the average return of all outcomes based on the probability of each outcome. So different outcomes, each outcome has a different probability, and you multiply the outcome in terms of monetary reward or a loss by the probability, and you sum up all the result. That is what we call the expected values. So the simplest formula we are using expected value is the average outcome out of random variable x. So it's a total of sum of x times p of x. So this is a summary of what the definition of the expected value. So about the total probability is, suppose that x can take some different values, x1, x2, xn. Each outcome is associated with the different x values. Right? Then the total probability for each outcome, for all the outcomes, is equal to 1. This is what this means. Total probability for all outcomes is 1. And then I from 1 to n here, x equal to xi, probability of x equal to xi, meaning this represents each outcome, and p represents probability. So p of x means probability of random variable x. Probability of random variable x. Here, random variable represents outcome. So the mean or expected value of x gives the average value of different outcomes with the corresponding probability. So here, mu of x represents the average outcome, average return of all outcomes. E of x represents expected value, and they are the same term basically. And that's equal to sum of this symbol means sum up all the each outcome with the corresponding probability, and then here the outcome is in terms of monetary reward or loss. So and then you sum up all this product and we get a result. So concept expected value describes the expected monetary return in the real world in terms of finance. We're talking about monetary return, of experimental observations. And here, again, this is the formula we are using. U of x represents average return of all outcomes. E of x represents expected value. And we are using this formula to calculate the expected value. All right, so now let's take a look at a concrete example, see how we apply this expected value concept to measure the projects. So in this case, investment in project A will result in a loss of 26,000 with probability of 0.3, 30% of a chance you end up with a loss of 26,000. Break even with a probability of 50%, 0.50 means 50%, will result in a profit of 68,000 with probability of 0.20. So we look at this total probability here, sum of those three values, 0.3, adding 0.5, adding 0.2, that's 1. So total probability is always 1. because these three outcomes includes all the possible outcomes. And we will look into each outcome here. So here we will create a table. So the table is easy to do. So we have different outcomes. First outcome is ending up with a loss. Second outcome with a break even. Break even indicates no profit, no loss. The last one is end up with a profit. Okay. We have three different outcomes, and each outcome here actually represent a monetary reward or loss. So in the loss case, we have 26,000 loss, minus 26,000 because it's loss, right? So deduct 26,000 from your bank account. Break even indicates $0, meaning no profit, no loss. And then the profit case is 68,000 profit. And each outcome has a probability associated. First one, for the loss case is 0.30, 30% of chance. Break even is 50% of chance, right? 0.50. And profit case is 0.20. So now, based on the formula, we will get x times p of x. And you just multiply those two. And we're going to sum up each first outcome times the probability. So we end up with a negative 7,800. Multiply negative 26,000 by 0.3. And 0 times 0.50, that's 0. And then we have 68,000 times 0.20. That's 13,600. Then we just sum up all those outcomes and then we get a result. So here the expected value is the average return of all outcomes, which is the summation of x times p of x. Right. So we sum up all of this. We get negative 7,800, adding $0, adding 13,600. Yes, okay, and then we combine the result. So we end up with 13,600 minus 78,000. That will turn out to be 7,800. So meaning, no, actually, this answer is not 7,800. It should be 5,800. All right, so 13,600 minus 7,800, that's 5,800. So that means the project A will give us average return of $5,800. Now let's take a look at project B. So for project B, investment in project B will result in a loss of $71,000 with probability of 0.20, break even with probability of 0.65, profit of $143,000 with probability of 0.15. Still, we're gonna multiply this to get a result. Yes. So first of all, we're gonna create a table, just like the so this is for project B. Create a table like this. So we have different outcomes, then we're looking at each outcomes here. So the first outcome is very similar to project A. So as a manager, you will evaluate all different projects and then pick the better project based on the expected value. The loss similarly break even, and the last one is profit. So the loss, so monetary loss is 71,000. Break even $0, and then the profit is 143,000. each one associated with different probabilities. First one probability is 0.2. Second one probability is 0.65. The third one probability is 0.15. Okay, so now you multiply this, the outcome in terms of monetary reward loss, multiplied by the probability associated with each outcome. So negative 71,000 times 0.2, that is 14,200. 14,200. 0 times 0.65, that's $0. And then 143,000 times 0.50. And that turned out to 21,450. 1,450. You combine this, we get total return. So the expected value here for the average outcome. Average return of all outcomes is the sum of x times p of x. So sum of this, 14,200 plus 0 plus 21,450. So you find the difference among this. Let's see what that is. So 21,000, yeah, minus 14,200. Turn out to be 7,250. So this is the average return. If you look at the previous project A, $5,800 return. Project B, $7,250 return. So the comparison is pick project B because project B provides better expected value or average return. So project B provides better average return. Which is a better product? Yep, so that's how you compare different projects based on the expected value. So a Lions Club, local Lions Club runs a raffle. A ticket costs $100. 1,000 tickets are sold. There's one first prize, a $25,000 Dodge pickup truck. Two second prizes of 15,000 John Deere tractors. There are four third prizes, $8,000 Honda riding mowers, and five fourth prizes of 650 steel chainsaws. What is the expected value of your winning if you buy one ticket in this lottery? Okay. So I'm gonna put into the Excel since there's not enough space yet. So put into Excel and I show you how to do this in Excel. Copy the here. Wrap the cell. Okay, so this is the question here. I'm gonna just quickly run through this out here. This okay, so first of all, we're gonna create a column. Call this. So the outcomes, right? We're gonna look at all the outcomes. No, I think it's better using a different platform to do this. I'll transfer those into the Excel in a second. I'm putting the note, and then I'm going to quickly create a table on a note, and I'll go from there. Save this. Now let's create a table first, right? Let's summarize all these outcomes first. Okay, so we have different outcomes here. So first outcome is winning the first prize. Second outcome is winning the second prize. And then the third outcome is winning the third prize. And then the fourth outcome is earning the fourth prize. And most of people will win nothing, right? That's also a possible outcomes here, meaning no prize. So we have 5 different outcomes here. And then we look into each monetary reward and then associated probability. So win the first prize, you end up with a $25,000 pickup truck. But remember, you pay $100 for the ticket. So the net gain or net loss, in this case, net gain or loss, X represents net gain, net profit or loss, right? So net profit will be 25,000 minus 100, which is 24,900. Get that. And secondly, we have a second prize of $15,000. So second prize, $15,000. That's total payout, but we have to deduct the upfront cost, which is $100 minus $100. So this turned out to be 14,900. That's the second prize. The third prize is $8,000. Honda mowers minus $100, so this turned out to be $7,900. And the fourth prize will be $650 transfer at a minus $100 cost, so it's $500, $550 profit. And no prize when you, and most people win no prize, right? Because 1,000 tickets, only so many prizes are there. So there'll be loss of $100. Now we look into each probability. So only one first prize. This indicates we have 1,000 tickets. Only one of them is first prize, is 1 over 1,000. So the probability is 0.001. Okay. And for the second prize, there are 2 second prize. So 2 people win second prize, 2 over 1,000. So it's 0.002. And we know there's 4 third prizes. So 4 over 1,000. 0.004. We have 5 fourth prizes, 5 over 1,000. 0.005. And then the remaining people will have no prize, right? So total probability here will be 1. So 1 minus 0.001 minus 0.002, minus 0.004, minus 0.005. Now we do x times p of x. So it's 24,900 times 0.001. And that would give us $24.90. Right? I mean, average return from the first price, second price 14,900 times 0.002. So this turned out to be $29.80. Third price is 7,900 times 0.004. See what that is. 0.004. And that's $31.60. Multiply 550 0.005. This turned out to be $2.75. This total probability here will be 1 minus 10, 12. So 1 minus 0.0012 is 0.9988. Okay. One minus 0.012. So it's 0.988. So now you multiply negative 100 times 0.988, and this turned out to be negative 98.8. If you combine all this, that's the expected value. In this case, expected value is equal to average outcome. All these returns, the sum of this negative 98.80 plus 24.90 plus 29.80 plus 31.60 plus $2.75. Then we get a result. Let's see what that is. Minus this result is negative 9.75. That means on average, you are expected to lose $9.75 every time you play the game. On average, you expect to lose $9.75 every time you play the lottery. Average return gives us very good indication of what we are looking at. All right, so totally up to you, right? So it's not building a hard return. So if you just buy one ticket, you expect to lose $9.75. And we can easily do this in Excel. Let me just quickly show you how to do this in Excel, right? So let's see. So first of all, we look at all the outcomes, and then x value, and then p of x. And then we do x times p of x. All right, so we have 5 different outcomes, so 5 columns, body, center, and then to all borders. Look like a table, right? So first outcome is first price, and second price, third price, fourth price, no price. Okay, so for the first price we get 25,000 minus 100. So I'm going to put in all this one with the dollar sign. This one with the dollar sign. Okay. And second price, that's 15,000 minus 100. That, and third price, that will be 8,000 minus 100. Okay. Fourth price, it's going to be 650 minus 100. Okay, and then last price is $900. And maybe use format this. Make it negative number. Okay, so the probability. Oh, that's okay. Put in parentheses meaning negative, right? So first one is 1 over 1,000. That. Second one is 2 over 1,000. And 4 over 1,000. The last one is 5 over 1,000. And then the probability of winning no prize. We can also look at it as this, right? So total of 12 people winning prize, meaning 1,000. We have 1,000 people playing the game. Only 12 of them winning prize, meaning remaining 988 people not winning prize. Okay, so that would be this. That's why it's 0.98. Now you just multiply this by the cell, these three, that, and just drag it all the way to the bottom to get all these returns. If we sum up this, that is our return, right? So this is expected value. It's the same as what we did it by. So it's the result, no difference. If you use Excel, you can get it done much quicker for sure. Now let's continue where we left off here. Now let's look at example 3. You are considering investing in oil well. Your share of cost will be 250,000. If the well finds oil, you will receive $1,250,000. That means $1 million profit. The prospectus estimates that there's a 25% chance of striking oil should you make this investment. Okay, again. So this investment on 2 outcomes. You just strike oil, meaning you're gonna have a profit of $1 million. Not strike oil. Then you do not have any price. So in terms of monetary reward here, if you strike the oil, you get $1 million profit. If you do not strike the oil, then you have $250,000 loss. So probability of striking an oil is 25%, 0.25. Then probability of not striking oil, you only have 2 outcomes. Total probability is 1, is 75%, which is 0.75. So now you just multiply x times p of x. So 1 million times 0.25, that's $250,000. return from striking the oil. Another one, let's see, 250,000. .75. That's not good. Minus 187,500. And you combine these two, and then you get $62,500 profit. So the expected value, average return of all outcomes, is total of x times p of x. So sum of those two, 187,500 plus 250,000 is going to be profit of $62,500. So on average, you're having a profit of 62,500. Should you make this investment? The expected value is the profit. Usually, it's a good idea to invest in this project, but totally up to you, right? Depends on your risk level. Example 4. So you're betting $2 and select a 3-digit number between 000 to 999. You hit a number, you collect $300. Your net gain is then $298. Suppose you bet $2 on number 007. What is your expected value of the gain or loss? Similarly, we're going to create a table. There are only two outcomes. Either you win or lose, right? You win the game, you have net profit, net gain of $298. That's it. What we call it profit, right? Profit on this winning case. And then losing case, you're losing $2 at most. And the probability of winning, we know between 000 to 999 and 1,000 numbers. Adding 1, that's 1,000 numbers. Always remember including the first number. That's why I have 1 here. Just make sure it's 1,000 numbers. And then only one number is a winning number, which is 007. So it's 1 over 1,000 chance you are winning the game. So 1,001. And there's 999 losing numbers. Multiply that, I get 0.999. Okay. And sum of this, it should be total probability 1. So x times p of x. That will be 298 times that. That's 0.298 positive, right? And then 2 times 0.999. That's negative 1.18. So if you look at it, if you combine these two outcomes, the expected value here, average return of all outcomes, total of x times p of x, it's negative 1.998 plus 0.298. This turns out to be negative 1.70. So this means on average, every time you play the game, you expect to lose $0.70. You expect to lose $0.70. So, again, it's not a good idea to play the game, but still, there's chance of winning the game, so that's why still people playing this type of lottery games in real life. Now, the last topic in this section is about weighted average. So weighted average is like one special type of average. So we do total of the weight times x. So this is the formula on top right here. weight is the, and then the most famous application of the weighted average is the GPA. So as a college student, you expect to have a GPA, and every semester after you finish the class, once the professor posts a grade, you will get your GPA will be updated after the semester is over. And then weight here is number of credits, right? And then X here is what they call quality points. Each grade has a quality point, and we will look into that in a second, right? So in calculating weighted average, each number in the data set is multiplied by a predetermined weight. In this case, predetermined weight is number of credits. Practically, you calculate weighted average by multiplying each value in the set by its weight. You add up the products and divide by the product sum, meaning total credits, the sum of the all weights. Right? GPA calculation is a typical example of weighted average. I'm going to show you how to do this. Since you are a college student, you should learn this. Quite helpful. The student had the following grades in his or her first semester. What was her grade point average GPA after this semester? So we have all these different grades. So again, typically it's better, creating a table. I'm going to show you how to create a table, solve this. So stats course B+, biology A-, French B-, chemistry is A, and then history is C. And this is grade, and each grade has a quality point corresponds with the quality. And quality points is what we call X, right? And then credits is what they call W. So now I'm gonna show you how to look up this. If you go to just find the browser and show you how to find that. FITNYC. Register office. Grading scales. Look at this. So this is basically what this is. Okay, so this is from the register office, and they post this. Each grade has a quality point. I'm gonna copy this as a reference. Go back here. Go back to PowerPoint. So I'm gonna quickly paste it here. I guess I can't. All right. So we just have to look up, I guess. So P plus, if you look at quality points here, it will be 3.3. A is 4 points, A minus 3.7, B plus 3.3, B is 3.0, B minus 2.7, C plus 2.3, C is 2.0, C minus 1.7, D is 1.0, F is 0. Now go back to the PowerPoint. Now we have different grades here. So B plus is 3.3. A minus 3.7. B minus, I think that's 2.7. B minus is 2.7. That's right. And A is 4.0. And I see that's 2. C is 2. That's right. 2.0. All right. So now we multiply the weight times the quality points. So for stats course, you're earning W times X, which is 3.3, 3 times 3.3, that's 9. The 4 times 3.7, and that turned out to be 14.8. Multiply 3 by 2.7, that's 8.1. 5 by 4.0, that's 20.0. 3 by 2.0, that's 6.0. And you're going to sum up all these total product. So let's see what that is. Sum up 9.9, 20, and the total quality points here. So GPA is daily average. It's total of W times X over W. If you sum up all these credits, you get a total weight 3 plus 4, 7, 10, 15, 18. So the student attempted 18 credits for this semester. And if we sum up the last column, and we end up with W X, which is 58.8. I divide those two. So take this number, divide by 18. 58.8. I get a GPA. Usually you can run it to 2 decimal place. And that's turned out to be 3.27. Okay, so that's how we can basically calculate the GPA in this case. You can use the homework assignment to practice this and get familiar with the concept.